Hello dear students, welcome back to day 64 of 99% in 99 days. So as you all know, we have done with all the syllabus, we are done with revision, we have done with mock test and all, and now to ace our preparation we are solving the sample papers, right? So sample paper 1 is already solved and I hope that all of you would have watched that video, solved the questions, and in case you got any doubt you would have also commented, right? So in today's class we are going to start the second sample paper, and in this particular video I'll be discussing the solutions of chemistry from sample paper 23-24. okay, so you will be getting the PDF of this question paper in our WhatsApp channel, so please join the WhatsApp channel. Link of the WhatsApp channel will be there in the description section of this video. Okay, so yes, now let's get started. First let me tell you the pattern of the question. Okay, so in this particular question paper you will be having like 8 one-marker question which includes 7 MCQs and 1 assertion and reason question. In 2-marker there is 1 question, in 3-marker there are 2 questions, in 5-marker there is 1 question, and in 4-marker there is 1 question. Okay. Now moving forward, so we will first discuss all the 1-marker question. So the first question here is, identify the product which represents the solid state in the above reaction. Okay. So solid state, so if you now see, this is your barium sulfate. Okay, one second. Okay. So barium sulfate is produced in the solid state because it is a precipitate, right? So that is why option number B. Next, coming to question number 2. The color of the solution observed after 30 minutes of placing zinc metal to copper sulfate solution is. Now see, if you place zinc metal, okay, in copper sulfate solution, so we all know that copper sulfate is blue in color, right? But here a reaction takes place. What type of reaction? Displacement reaction, in which zinc displaces the copper from copper sulfate and we get zinc sulfate. Okay, and copper is deposited. Now this zinc sulfate is a colorless solution, okay, or you can say white or colorless. So the solution after 30 minutes appears to be colorless. Okay. Moving towards the third question here, mild non-corrosive basic salt. Okay. So basic salt means you should be knowing that we should have a strong base, okay, plus a weak acid. Okay. Now if you see calcium hydroxide, okay, it is not a salt, right? It is what? It is a base itself. So we can eliminate this one. NaCl is a salt, but NaCl salt is made up of what? NaOH plus HCl, right? And NaCl is a strong, NaOH is a strong base and this is a strong acid. So the salt produced here, NaCl, is a neutral salt, right? But in the question it is asked to find a basic salt, so we can eliminate this one. NaOH itself is a base, it is not a salt, so eliminate this one. Now if you see NaHCO3, okay, so NaHCO3 is made up of a base, that is NaOH, and an acid, that is H2CO3. Now this is a strong base and carbonic acid is a weak acid. So when a strong base and a weak acid combines, you will get a which type of salt? Basic salt. Okay, the correct answer here is option number B. Okay, next question number 4. On adding dilute sulfuric acid to a test tube containing a metal X, okay, you have metal X and you have added what? Dilute sulfuric acid. A colorless gas is produced when a burning matchstick is brought near it. Which of the following correctly represents the metal? Okay, so if you see here, it reacts with a metal. Okay, sulfur is not a metal, we can eliminate this one. Okay, silver is a non-reactive metal, we can eliminate this one as well. Okay, now coming to copper and sodium. So copper has a very special property that when copper reacts with any acid, okay, there is no H2 gas produced in that case. Okay, so that is why copper is also not the answer. Correct answer will be sodium, that is option number A. Okay. Let us see the next question here. Which one of the following correctly represents sodium oxide? Okay, so now if you see sodium, what is the electronic configuration of sodium? Okay, sodium electronic configuration is 2, 8, 1. Oxygen electronic configuration is 2, 6, right? Now if you know sodium will lose this one electron and oxygen can gain 2 electrons to become octet, right. So sodium will lose 1 electron, so it will become Na plus, oxygen will gain 2 electrons, so it will become O2 minus. So to form a compound, if I do crisscross, it will become Na2O. That means it has 2 sodium and 1 oxygen, right. So now if you see in this particular, sodium has lost 1 electron. Okay, here you can see there is 1 sodium and 2 oxygen, that is wrong. Here we see 2 sodium, 2 oxygen, no, I need 2 sodium and 1 oxygen. Here 2 sodium, 1 oxygen, this can be there. Here you see there is 1 sodium and 1 oxygen, that is also not correct. So that is why option number B here. Okay, very simple question. Next, moving to question number 6. An element with atomic number dash will form a basic oxide. Now see, for basic oxide we need metal oxides. Okay, generally metals form basic oxide, and in the electronic configuration of metals, in the valence shell we have 1, 2 or 3 electrons. Okay, so here you can see there is 11 where we have 1 electron in the valence shell, so this is metal and that will form a basic oxide. Okay. Next, question number 7. An element M has 50% of the electrons in the third shell as in the second shell. The atomic number of M is. Okay. So what we can do is we can just write down this electronic configuration. For 10, if I want to write, it is 2, 8. Okay. Next, for B, if I want to write, it is 2, 8, 2. Next, 14, it is 2, 8, 4. Right. D, if I write, it is 2, 8, 8. Okay. Now, first of all, the question is saying that there are like third shell is also there, right, but in the first there are only 2 shells, we can eliminate this option. Now these 3 options we can consider. Okay. Now what is the saying? The electrons in the third shell means the electrons in the third shell. Okay, sorry, an element M has 50% of the electrons filled in the third shell as in the second shell. Means second shell, how many electrons are there? Its 50% is there in the third shell, means half is there in the third shell. Now here if you see, in the second shell if you have 8, in the third shell you have 50% of this one. So that has to be the answer, that is your option number C. Okay. Next is your assertion reason question. Rusting of iron is an endothermic in nature. Okay. As the reaction is slow, the release of heat is barely evident. Okay. So here both assertion and reason is correct, and reason is the explanation. Assertion and reason are true, reason is not the explanation. Assertion is true, reason is false, assertion is false, reason is true. So first let us know that whether it is a exothermic or an endothermic process. Okay. So now if you see here, there is endothermic is written. Okay. Now this reaction, okay, the redox reaction that happens in this particular case, okay, you can know rusting of iron is nothing but reaction of, I can write reaction of iron with oxygen. Okay, and reaction of any element with oxygen is a type of combustion reaction. Okay, and you should remember combustion reactions are always exothermic. Okay, so that is why this is endothermic is a wrong statement. So if assertion is false, there is only one option, that is option number D. Okay, fine. Next, moving to 2 marker questions. So the first question is, dilute HCl is added to zinc granules. How will you prove that chemical change has taken place? Support your answer with 2 arguments. Okay, so for chemical change there are different visible observations you have to say, like the change in temperature, evolve in gas, or change in any phase, change in color. These are the things that you can represent. So if you know when zinc reacts with HCl gas, what is produced? Salt we get, that is zinc chloride, and we get H2 gas. Okay, to balance it I'll write like this. Now this H2 gas which is produced, that can be seen, and if you burn like if you bring a burning matchstick near this H2 gas, you can hear a pop sound, right, and the temperature also changes. So these are the changes that you can write down. So I'll show you how to write the okay. So you can write any 3 of the point: bubbles of gases or evolution of gas, that is the first thing. Which gas? Hydrogen gas. Second, change in color. Okay, zinc is generally silvery in gray, silvery color, it changes to black because of formation of zinc chloride. Next, change in temperature. Okay, so gas, color and temperature change. Any two you have to write. Okay. Next, coming to section C, that is 3 marker, where we have 2 questions. Okay. So the first question here is, the given reaction shows one of the process to extract the metals like iron and manganese. Okay. Give reason why the above reaction is known as a thermite reaction. First question. Identify the substance oxidized and reduced in the above reaction. Okay. Give a reason why aluminium is preferably used in thermite reactions. Okay. So first of all, why thermite reaction it is called? Because heat is involved, right? Heat is produced in the reaction. It is an exothermic reaction, so it is a thermite reaction. Next, which is oxidized and which is reduced? Now you see, if manganese, you see MnO2 to Mn, oxygen is removed, so manganese is undergoing reduction. So it will behave, manganese is undergoing reduction. And if you see Al to Al2O3, oxygen is added, right? So Al is undergoing oxidation. This is done. Next, we have give a reason why aluminium is preferably used in the thermite reactions. Okay, so when we produce, so because of the heat produced, that is why aluminium is used. So now let us see the reactions answer, how you can represent. So the above reaction is known as thermite reaction as the reaction is highly exothermic reaction. You can see how it is exothermic because heat is produced here. Next, the substance which is undergoing oxidation is your aluminium, and substance undergoing reduction is MnO2. Now why aluminium is used? You can write down aluminium is more reactive than Fe or manganese. Okay. So aluminium is preferably used in thermite reactions as it is placed above Fe and manganese in the reactivity series of the metal. Okay, or it is more reactive than iron or manganese. So if it is more reactive, right, then only it can replace this manganese or iron. It can replace, and when it replaces, heat is generated, right? Okay, next, coming to your second 3 marker question. So here we have option also. An element M with electronic configuration 2, 8 and 3 combines separately with Cl minus and SO4 2 minus ions. Okay, so there is an M atom, there is an element M. When you see 283, you can easily guess that its oxidation or valency is +3. Separately reacts with Cl minus and SO4 2 minus. Okay, fine. Next, write the chemical formula of the compounds formed. This is very simple. You know this crisscross rule, right? So now if I have, let me write it like this. Okay. So now suppose I have this M plus 3 and Cl minus. Okay. So what will happen? Crisscross will take place and you will get MCl3. Then if you have M plus 3 and SO4 2 minus, okay, you can just crisscross it, you will get M2 SO4 whole 3. Okay. Now predict with the suitable reason the nature of the bond formed by the element M in general. So you can see this is a metal. Okay, so what type of bond it will form? It will form ionic bonds. Okay. Next, how will the electrical conductivity of the compounds formed vary with respect to M? So electrical conductivity, since it is an ionic compound, it will conduct electricity in molten or in the aqueous state. Okay, fine. That is, so if you write these 2 structures, you will get 1 mark. Okay, ionic conductivity 1 mark, electrical conductivity, what type of bond, that is 1 mark, and then electrical conductivity, if you write why it conducts electricity, that will give you 1 mark. Okay, so total 3 marks. Next question, I'll show you how to write the answer. Okay, let us first show me, okay, this one. So MCl3 and M2 and SO4 whole 3, half of that carries 1 mark. M in general forms ionic bond, this will give you 1 mark. And it can acquire a stable, okay, why it forms an ionic compound? Because it will, if it loses 3 electrons, it will gain a stable electronic configuration. Next, it will conduct electricity in the liquid or in the molten state, but not in the solid state. Okay, so that is your 1 mark. Compounds formed will conduct electricity in the liquid and in the molten state, but not in the solid state, in contrast to M. So what was the question? How will the electrical conductivity of the compounds formed vary with respect to M? Okay, this part is also there. With respect to M, how it will vary? So aluminium is a metal, so that is why it can conduct electricity even in the solid state, right? It is a metallic conductor. But when it forms compound MCl3 and M2SO43, these are compounds, ionic compounds. So we need free ions, so that is why the ionic compounds can conduct electricity when they are in the molten state or in the aqueous state. Okay. Next question, a reddish brown metal X when heated in air gives a black compound Y. Okay, so when we have a compound X, so let me just write it on this side. We have a compound X, so when you heat it, okay, it gives a black compound Y, okay, which when heated in presence of H2 gives you back X. So if you just heat it in presence of H2, we get X back, okay. Now X is refined by the process of electrolysis, okay, X is refined by the process of electrolysis. This refined form of X is used in electrical wiring, okay. Identify X and Y, okay. Draw a well-labeled diagram to represent the refining of X. So when it is told that it is refined, so I think all of you might have guessed it is also used in electrical wiring. It is nothing other than copper, right. So when copper reacts with oxygen, it forms copper oxide, and if you treat with hydrogen, it undergoes reduction and you get back your copper. You can see the, so X is copper and Y is copper oxide. Now this diagram is there in the book, the electro refining of copper. So at anode what will happen? Copper will be lost, and at cathode copper will be deposited. You have to take an electrolyte and the impurities will be deposited, anode mud, okay, and you have impure copper on the anode side and the pure copper on the cathode side, okay. That is the purification diagram. Clear? This is there in your book. Next, coming to section D, 5 marker questions. Okay, Rahmat classified the reaction between methane and chlorine in presence of sunlight as a substitution reaction. Support Rahmat's view with suitable justification and illustrate the reaction with the help of a balanced chemical equation. So first you have to justify why it is a substitution reaction, and then you also have to write the reaction, okay. So this will carry 2 marks. Writing the reaction and justifying why it is a substitution reaction. Next, B, chlorine gas was prepared using the electrolysis of brine solution. Write the chemical equation to represent the change, okay. Identify the product formed in the process and give one application of H, okay. So here this carries 3 mark, I will tell you why. If you write the chemical reaction, you get 1 mark. Identify the product and write its one use, that carries 1 mark. Similarly, there you know there are 2 products will be produced, H2 and Cl2, so H2 and NaOH, sorry. So H2, if you write the term and write its one use, you will get 1 mark. NaOH, you write the term and write its one use, it will give you 1 mark, okay. So here 3 mark and here 2 mark, that is 5 marker question. So first, why is it a substitution reaction? So if you know, if I am reacting CH4 with Cl2 in presence of sunlight, so what I am getting? CH3Cl. So the hydrogen and byproduct is HCl. So the hydrogen of CH4 is replaced with chlorine, right, because chlorine is replacing the hydrogen. It is called a substitution reaction, right. So here you can see, first Rahmat's observation is correct, as the hydrogen atoms are substituted by the heteroatom, that is chlorine, okay. Reacting, you have to write the reaction. So CH4 plus Cl2 gives CH3Cl plus HCl. This carries 1 mark and this carries 1 mark, okay. Next one is the reaction electrolysis of NaCl. So NaCl plus H2O will give you NaOH plus Cl2 plus H2. That will give you 1 mark. Next, the product here NaOH, okay, they mentioned that is half mark, and it's any one use, okay. I have given you 4 uses, any one use you can write, like artificial fibers, paper making, preparation of soaps and detergents, degreasing of metals, any one. And another product is H2 and its one use, it is used in fuels, it is used in the manufacture of ammonia. Any one you write, you will get half mark, 1 mark, here 1 mark, here 1 mark, and here 2 marks, okay. That's this question. Now let us go to the OR question. Okay, right now while doing certain reactions, observe that heating of a substance X with vinegar like smell with a substance Y, okay. So you are heating X with Y, okay, and Y has vinegar like smell, okay. which is used as an industrial solvent in presence of concentrated sulfuric acid. Okay, in presence of concentrated sulfuric acid on a water bath gives a sweet smelling liquid Z. So you get Z, which is a sweet smelling compound. So I hope from that you must have guessed that this is an ester, right? Next, having a molecular formula of C4H8O2. So this is C4H8O2. Okay. Next, when heated with caustic soda, so when you heat this Z with caustic soda, that is NaOH, okay, Z gives back the sodium salt of the compound Y, okay, you get sodium salt of Y, sodium salt of Y, okay. Identify X, Y and Z. So if you identify X, Y and Z, you are getting 3 marks, okay. Next, illustrate the changes with the help of a suitable chemical equation. So if you have 2 reactions, you just write 2 reactions, you will get another 2 marks, so total 5 marks. So now if you know that Z is an ester, so ester is made up of 2 things, right, acids and alcohols. So if esters are made up of acids and alcohols and Y is a vinegar type compound having a smell of vinegar, then that is nothing but your acetic acid, right, because we know the one of the like important component of vinegar is acetic acid, and here also you are getting sodium salt of Y. So sodium salt is generally formed by the acids, and here you see ester is having 2 carbon, if one of them, sorry, ester is having 4 carbon, if as one of them is acetic acid which is having 2 carbon, the another 2 carbon must be from here, and X has to be an alcohol of 2 carbon which is nothing but your ethanol, right. So what from that what we can conclude, that X is ethanol, I can write ETOH, and Y is acetic acid, right. So we see here, one second, okay. So you can see X is your ethanoic acid, acetic acid or CH3COOH, okay, one second, X is vinegar, okay, one second student, sodium salt of the compound Y, heating a substance X with a vinegar like with a substance Y, okay. So yes, here is a small mistake, okay, so this is Y, okay, this is Y and ethanol is your X as I told you, okay. And then if you write Z is your ester, X and Y will react, this is your Z which is an ester formed. Now the reaction between this one, ethanoic acid plus ethanol, okay, ethanoic acid plus ethanol in presence of what, ethanoic acid plus ethanol in presence of concentrated sulfuric acid will give you an ester, okay. Next, ester in presence of NaOH, okay, that will break down saponification reaction. So CH3COONA, okay, plus C2H5OH, okay. So that will be the product formed. Clear? Fine. Now moving towards section E, 4 marker question. Okay, the first question here is substance C is used as a preservative, okay, fine. The question, the table given below shows the hints given by the quiz master in a quiz, okay. So first, substance C is used as a preservative, okay. Substance C has 2 carbons, okay, and C is obtained by the reaction of A in presence of alkaline potassium permanganate followed by acidification. So from here can we guess something, C is having 2 carbons, okay, and A, it is prepared from A with the treatment of potassium permanganate solution which is a very strong oxidizing agent, right. So A, which means if you use this one, it is used for conversion of alcohols to acids, right. So we can say that C is nothing but an acid of 2 carbon which is nothing but ethanoic acid. So from here what I got, C is ethanoic acid, C is ethanoic acid, that is okay, fine. Next, misuse of A. So what is A here? A also I guessed, that is your ethanol, C2H5OH, okay. Okay. Now Misuse of A in industries is prevented. So ethanol use is prevented by adding methanol, benzene and pyridine to A. So that is A is made unfit for drinking, right, by adding these particular compounds. Next, F is formed by heating A in presence of concentrated sulfuric acid. So F is what? If you heat it, you will get A, right? So that is ethanol. Okay. F is formed when A is, so F is formed, sorry, here I will change it. Okay. F is formed when A is heated. Okay. So A is heated, you will get F. That means what must be A here? See, I already told you A is an alcohol, okay, ethanol. When you heat it, you are getting F. So if you remember, this is your reaction. Ethene, you will get dehydration reaction is there. So F is ethene. Now F reacts with hydrogen gas in presence of nickel and palladium catalyst. So F reacts with hydrogen. So if ethene is there and if you react with hydrogen, what we will get? Ethane, right? So here coming to first thing, based on the above hints, answer the following questions. Give the IUPAC name of A and F. So we have already identified, right? F is ethene, A is ethanol. Okay. So if I want to write, A is ethanol, okay, and F is ethene. Next, illustrate with the help of a chemical equation the changes taking place A to C and A to F. A to C, A to C, that means C2H5OH, okay, to C, that is CH3COOH. This is what? KMNO4. Clear? This is done. Next, A to C, and we have one more, A to F. So if you see A to F means your alcohol to alkene, okay, or I can say ethanol to ethene, ethanol to ethene, okay, that is one more reaction. F is formed on heating A in presence of, so these two reactions I have told. Next, name the chemical reactions which occurs in step 2 and 5. Name the chemical reaction. Step 2 is this one, right? This one, A to C is your step 2. This is your oxidation reaction, okay, and step 5 is this one, that is your hydrogenation reaction. Sorry, step 5, F reacts with hydrogen gas, so that is your hydrogenation reaction. So now this is a 4-marker question. So you can see first ethanol and ethene, the IUPAC name, here the reaction. So ethanol, if you take alkaline KMNO4, you will get sodium salt, H plus you will get back the acid, and here that is your reaction, what I'll say, ethanol you take hot concentrated sulfuric acid and you take alkene, okay. So here 1, 2, 3 and 4 marker, 4 question, write these two, and the OR question was which two reaction? The first one is your oxidation reaction and the next second one is the addition reaction, or you can write hydrogenation reaction, okay. Name the chemical reactions which occur in step 2 and 5, that is done. Next, identify the compound formed in these steps if A is replaced with its next homologue. So A is ethanol, if you replace it with the next one, that is your propanol, right? So what will be the product? Will be getting propene, okay, propene and propanoic acid. Fine. So that's all in this class, students. I hope you have solved these questions, and if you have any doubt in any question, please comment down. I'll definitely address to it. So thank you for watching, and do not forget to subscribe the channel.